We continue the numericals based on the impulse and momentum. And the question is, a ball is moving. A ball is moving with a momentum of 5 kg meter per second. A ball is moving with a momentum of 5 kg meter per second. Strikes against a wall. Ball strikes against a wall. So let AB is the ball, and ball strikes against a ball at an angle of 45 degree. Suppose this is the horizontal, this is the point O, and a ball strikes the wall at point O, and its momentum is P. The momentum is P, and the ball strikes the wall at point O at an angle of 45 degree. Then the ball is reflected at the same angle. Ball is reflected at the same angle. Means it is reflected by an angle of 45 degree. Angle of reflection is also 45 degree. And this is the angle of incidence, which is 45 degree. Now there must be two components of the momentum, because it is making an angle 45 degree with the horizontal. So the vertical component of this P is P sine 45 degree, and horizontal component will be inward, which is P cos 45 degree. In the same way, this is again momentum. So it has also two components. Vertical component lie in downward direction, which is P sine 45 degree, and its horizontal component lie in horizontal direction, which is P cos 45 degree. So there are two components for the incident momentum, and also there is two components, vertical and horizontal, for the reflected momentum. Now we calculate change in momentum along the vertical direction and change in momentum along the horizontal direction. We calculate change in momentum along the vertical direction and the change in momentum along the horizontal direction. So change in momentum along vertical direction. So it has two vertical components, P sine 45, P sine 45, and both have the same direction. So both have the same direction. So P1 minus P2 means P sine 45 degree minus P sine 45 degree, and it gets cancelled, and we get the change in momentum along vertical direction is 0. Now we calculate change in momentum along the horizontal direction. Change in momentum along horizontal direction. We calculate change in momentum along horizontal direction, and its formula will also be P1 minus P2. If we take the momentum, the component of momentum which is going inward, both have the opposite direction. So when we take this component which is going inward towards O. When we take as positive, then this component which is going outward, this component will become negative. So let this is P1, this is P1, and this is, let this is P1 and this is P2, P1 and P2. So change in momentum along horizontal direction. So this would be taken negative, which is going away from the O. So minus P cos 45 degree. And minus comes for formula because P1 minus P2, and this is going inward. So it must be positive. When we have taken outward direction as negative, then inward direction would be taken as positive. So minus P cos 45 degree and minus P cos 45 degree. And that is minus 2P cos 45 degree. And the value of cos 45 degree is 1 by root 2. So we get minus 2P into 1 by root 2. And the value of P is also given. The value of P is 5. So minus 2 into 5 into 1 by root 2. 1 by root 2. And the value of 1 by root 2 is around 0.707. So minus 2 into 5 means minus 10 into 0.707, which is minus 7.07. Minus 7.07. This is the change in momentum along the horizontal direction, and its unit is, momentum is equal to mass into velocity, and the unit of mass is kg, and the unit of velocity is meter per second. So this is the change in momentum comes to be minus 7.07 kg meter per second. And in vertical direction, change in momentum is 0. And the minus sign indicates that change, the direction of change in momentum is away from the wall, The direction of minus sign shows that the direction of change in momentum is away from the wall, because the direction which is away from the wall we have taken as negative. The direction away from the wall we have taken as negative. So the direction of change in momentum is minus. So minus sign only shows that the direction of change in momentum is away from the wall. Now the next question, a machine gun fires a bullet of mass 40 gram. A machine gun fires a bullet of mass 40 gram. Fires a bullet of mass 40 gram. A machine gun fires a bullet of mass 40 gram with a speed of 1200 meter per second. With a speed of 1200 meter per second. A machine gun fires a bullet of mass 40 gram with a speed of 1200 meter per second. The person holding the gun, the person holding the gun can exert, the person holding the gun can exert a maximum force of, can exert a maximum force of 144 Newton. The person holding the gun exert a maximum force of 144 Newton on it. So what is the number of bullets on it? What is the number of bullets that can be fired? What is the number of bullets that can be fired from the gun per second? We have to calculate the number of bullets that can be fired from the gun per second. So firstly we suppose that maximum number of bullets, let the maximum number of bullets fired per second be n. N is the maximum number of bullets that can be fired per second. Then we calculate the change in momentum of n bullets. Change in momentum of n bullets. So change in momentum of one bullet, change in momentum, mass into change in velocity means m into v minus u, and change in momentum of two bullets, so 2m into v minus u, but we are finding change in momentum of n bullets, so n into m, and change in velocity v minus u. This is the change in momentum of n bullets, n into m into v minus u. Now we have given n as it is, mass we have given 40 gram, so 40 upon 1000 gram will be converted into kg. Velocity is 1200 meter. Machine gun fires a bullet of mass 40 gram with a speed of 1200 meter per second. 1200 minus 0. So n into 40 upon 1000 into 1200 minus 0, which is n into 40 upon 1000 into 1200. 2 0 gets cancelled, 1 0. So this is 12 into 4, 48 n, and its unit of mass is kg, and unit of velocity is meter per second. So we find the change in momentum of n bullets equals to 48 mn. There is n also. 48 n. 48 n kg meter per second square. Now we know that change in momentum is equals to impulse. Change in momentum equals to impulse. Change in momentum is equals to impulse. And change in momentum we got 48 n, and impulse is equals to force acting for a short interval of time, F into t. Then n is equals to F into t upon 48. The value of force is 144 Newton. The value of force is given 144. Time is 1 second because it is given per second upon 48. So we get the value of N is 3. So the result is 3 bullets per second be fired. In 1 second, the number of bullets be fired from the gun is 3. Now let us discuss another question. The question is, we are given a figure. Figure shows an estimated force time graph for a baseball struck by a bat. Figure shows. Figure shows an estimated force time graph. Force time graph. Force time graph for a baseball struck by a bat. For a baseball struck by a ball. Figure shows the force time graph for a baseball struck by a bat. Struck by a bat, and the graph is force and time graph 6,000, 12,000, 18,000. Force is taken on y-axis and time is taken on x-axis. And the force, the value of force is 6,000, 12,000 and 18,000. 6,000, 12,000 and 18,000. This is the value of force which we are given, and time is given 1 second, 2 seconds and 3 seconds. 1 second, 2 second, and 3 second. And between 1 second, it started from 1 second and there is 2.5 second. And 1.5 second and 2 second at 12,000 force. This is 1.5 second and this is 2 second. A, B and C. The point is A, B and C. This is 1.5 second and this is 2 second, and at point C there is 2.5 second. And force is given in Newton, time is in second. Force is given in Newton, time is given in second. 6,000 Newton, 12,000 Newton and 18,000 Newton. So we have to find the impulse and force. Find the impulse acting the force from this curve. Find the impulse delivered to the ball. Find first part, impulse delivered to the ball. The second part we have to calculate, force exerted on the ball. Force exerted on the ball. And the third we have calculate the maximum force on the ball. Maximum force on the ball. So for finding the first part, which is we have to calculate impulse, we find the area of triangle ABC. For finding the impulse, we find the area of triangle ABC. So impulse is equals to area of the graph, means area of triangle ABC. For finding the impulse, we use the formula, the area of triangle. And area of triangle is equals to half into base into height, which is 1 by 2 into base. From 1 to 2.5, the difference is 1.5. From 1 to 2.5, there is a difference of 1.5. From 1 to 2.5. So 2.5 minus 1 into height. Height is 18,000 Newton. 18,000 Newton. So we get 1 by 2 into 1.5 into 18,000. 1 by 2 into 1.5 into 18,000. So decimal gets cancelled. And 3 5 ja 15, 2 5 ja 10, 2. So 3 upon 4 into 18,000. So 18 into 3, 54 upon 4 into 10 raised to the power 3. 54 by 4 into 10 raised to the power 3. and this will divide it. This will also written as 5.4 upon 4 into 10 raised to the power 4. 5.4 upon 4 into 10 raised to the power 4 and 5.4 divided by 4. It comes round off 1.35 into 10 raised to the power 4. And the unit of impulse equals to force into time, so Newton second. This is the value of impulse, which is equal to the area of the graph. Now we have to calculate the force. So force equals to impulse upon time. Impulse is equals to force into time, F into T. So force equals to impulse upon time. Force equals to impulse upon time. And impulse we have calculated 1.35 into 10 raised to the power 4. And time duration is 2.5 minus 1. 2.5 minus 1, which is 1.35 into 10 raised to the power 4 upon 1.5, and its value comes to be 9,000 Newton. 9,000 Newton. This is the force exerted on the ball, and the maximum force on the ball. So maximum force is already it is given at point B. The maximum force exerted is 18,000 Newton. So maximum force, this is second part, this was the first part, and the third part which we have calculated, maximum force on the ball, which is 18,000 Newton. So we calculated the impulse force exerted on the ball and the maximum force on the ball.